that's what this is. And right off the bat, if you compare the files we have got, you'll see that there are a couple of extra files. In the one with no core data, you will see that this event.swift is not there. And this file is also not there. It ends in .xc data model D or data mode ID. Model D, I think it is. So that's what this is. So these two files, right? And we will come and examine these. And that's where we'll start understanding what core data is doing. But before we do that, let's just run it. And what I want to do is to be able to see it side by side, I'm going to run it on a separate simulator. So this is going to launch uh, another iPhone device here. So this is the first one with no core data. Like we saw the functionality, this part we have seen before we create. And if we open and close the app without killing it, the data stays in the memory. If we kill the app or if we were to reinstall it, it would be gone. So I've just killed the app, and this is the version with no core data. All the entries we created are gone. And pardon the repetition, I'm just doing it for the benefit of the video because I didn't start the presentation in time so that everything gets covered quickly. And now when this one launches, we will see that it gives us the functionality. You know, whatever we are trying to do here, you want in a real world app, you want the information to be saved. So see this part, when I click the plus, it is the same. This part is just the same. It shows the title of the object right here in the detail. And if I were to just stop the app temporarily without killing it and open it, it's all here. And now I'm going to do this. I'm going to kill this app and now I open it. See, it all came back. It is saving the information already. So when we said use core data, it gave us all what we need to save this data model. That there is an object which is the title and it is in a list. This gets saved. That's what we want to understand, how it is being saved. So we saw the difference and now we will understand why that difference is. So there are these bunch of things that I want to talk about. There is this file that I said is there, the XC data model and the event.swift. Let's start with this data model. So this is the file which is called the data model. And you will see that in this data model, there is an entity called event. And this entity has one attribute called timestamp, which is of the type date. That's our data, right? That's what we are saving. We are saving each one of these is an entity, and right now it has only one object, one attribute in it, which is the date stamp, which is this. So that is how this data model has been defined. In a moment, we'll see how to add, how to create this thing by ourselves. But right now, we are trying to understand what is going on. So yes, there is an entity, it's an event. The event, you can say when you click the plus, it's an event. It creates a new row and it's at this time. Now you see this event, there is an equivalent event.swift. What this does is when you have a core data model and you have an entity called event, it creates a class for you internally called event. And that class gives you access to these variables. Event.timestamp will give you access to this variable. So what is in this event.swift? This here is creating an extension of the event class that core data created. That class you don't see here. That is implicit. But this extension is explicit. You're saying that whatever that event class is that core data created, we are extending it by adding a function to it. And what is this function called? It's called create. What does it do? It basically is creating self.init. Self here is the event object of the event class. Init, you're creating a new object of that class within a context, which is managed object context. So just like in Android, we keep seeing that context, context, get context. Core data works with a context, managed object context. So all your core data functionality is residing within this context. So you're saying that this new object is getting created within this context. And then once that new object is created, you add a timestamp to it, which is the date at the moment when this code gets executed. And then you save it. So as soon as you put this code, you execute this, it will add a new item to that collection and it will get saved. Now, if we have a create function, stands to reason that we have a call to this create function. Where do you think that call is? Where would you put it? If you look at this, at what point does it get created and what leads to that?
And the plus button.
Exactly. Exactly right. So let's go to content view and let's see what the plus button is doing. This is our plus button and this is the action. So within this action, you've got, see, event.create. You're just calling event.create and you're passing an object here, the parameter in. And this in, if you recall, is a managed object context. It's basically an object of type NS managed object context. And in is just the label, and this is the variable name we use within this code here. But to pass it, we just use the label in. So that's what it did. It passed a few context in which to create this object. And as soon as you do this, let's now start backtracking. An event is getting created and inserted, right? So what is this? Where is this coming from? View context. This is where it is coming from. Here it is shown as two lines, but this is actually treated as one line of code. This is the what is called a property wrapper. And this is the variable name, the property name. So when you say add environment, environment is like a scope in which a variable has been declared. And this environment can be referred to from anywhere within the scope. Like, for example, if we had other views that share this environment, you can refer to this property without it being passed along to different views. That's what the environment does for us. So you're saying that retrieve something called a managed object context from the environment and pass it as a variable. So if this is, you are able to retrieve it, somebody else should have put it there, right? Otherwise it will come back as null. So we keep our detective work going. So we find that, okay, this somebody has put it, you can search, for example, you can search in the code, search for all the instances of this. So you can say find selected text in workspace, and you will see a bunch of places where it shows up. This is the current file. We've got it here. In the event, we have got it's the variable name that was being used. And then you see that in scene delegate. Scene delegate is a delegate which manages different instances of the same app. It's this, like they call them the scenes. Here is where it gets interesting. It says create the Swift UI view and set the context as the value for the managed object context environment key path. So this scene delegate is called anytime your app is opened. And what is it doing? It is creating, it is retrieving the context, and then it is pushing it into the environment. This is the code that does it. That's what enables that add environment property wrapper to retrieve it. You are saying that in the environment of the content view, push this, think of this as a key and this as a value. So this is the key, this is the value. Put this in the environment. So anywhere in content view and its sub views, it is available in the environment. That's what has happened here. And if you see the same scene delegate in the version with no core data, see all of that is missing. You have this much code. These lines should still be there on the other side. The content view is being instantiated, and then you say window scene and make visible, right? So that is what is happening. We've got this line extra to retrieve the context, and this is additional code to set it in the environment. But if you don't have this, the rest is the same as the other. So this is what the Xcode template did for us. It created the context, not actually not created. It retrieved it from the application, UI application, and pushed it onto the environment. So this is then available here as an environment object. And within this context, we created a new event. And this new event got saved, within the context, it got saved. So far, so good. We can see how it is being saved, but how is it being retrieved for display? How is the code making this list? Let's look at that. So this is the content view. This is the master view. And within the master view, so within the main view is embedded a master view object, which with some properties here. And what is the master view? The master view object is basically a list. It goes through a bunch of uh, event objects, whatever is available, one by one, and creates each one of them as a link, a navigation link to the detail page, to the detail view page. So you see, this is what it's doing. Each navigation link, these are all navigation links, each one of them, and they have a piece of text, which is basically the formatted date. And where is that date coming from? It's coming from the event that you saved earlier. This event is an object in this events array, and we are looping over it here. So how is this events array making it to this master view? Again, through the environment. What is happening is you have access to the environment, the context here, but for another reason. But really, this events array is coming from this fetch request property wrapper. So fetch request, what it does is you can describe what you want, and this fetch request, it requests from core data that information that you are asking for, and it creates all the property bindings. So what is this? This fetch request is saying that give me all the results. These are internal classes, fetch results, and this is a property wrapper saying that give me all the objects of type event in the context available and sort them like this. So you describe a sort descriptor. So here you are saying that sort them in ascending order of timestamp. See, because they're internally, they may be stored in any order. You don't know. They may be returned in any order, even if they're stored in a certain order. So you say, okay, just sort them and put them in this array events. And then when you say for each, it goes through all of those objects. And not only that, if this events object changes, which it does when you hit the plus button, a new one gets created. Due to the property binding, when it gets created, a signal is sent to this place saying, hey, this has changed. Update your view. So it does all of this again, and it shows you the new object. So when you say plus, it's added. That's what it's doing. And in fact, there is a difference between the two. I think this one does in descending order, if I'm not mistaken. Yeah. So this, the latest object is at the top here, the latest is at the bottom. Anyway, that's a difference in the way Xcode generated the template. And you could very well change it by changing this ascending to false, and it would do it in the reverse direction. So this is what core data has given us so far. Let me see if I have covered everything. I have to show you the app delegate. Let's look at the app delegate, and that would be a good time to take questions because this is, like I said right in the beginning, there is a lot going on here, and we need to make sure that the understanding comes. So in the app delegate, there is some more work going on. You see, because of the core data, there are a couple of functions. If we compare it to the app delegate in the version without core data, there are just three functions here. So did discard scene sessions configuration and did finish launching. These are the three. Here, those three are there, same three. And additionally, because we said use core data, it gave us this. It gave us a persistent container. Container is where all the data will be, and this is the name of the container, your app's name. And what it does is it loads the persistent stores and returns the container. And this is where your context is getting saved. So you get from the container, you retrieve the context. That's what happens. And if there are any changes when your app exits, if there are any changes, it will save it. And this is always going to be in a try catch block because there may be errors. You may want to handle those errors. If you are making a camera app and you're saving, let's say, photos to your core data model or even a regular file system, this try catch gives you a chance to tell the user, sorry, you could not save the picture, your disk is full. Pop an alert in the catch if that is the case. So we've got these two additional functions. And here there is a new thing, lazy variable. Have you seen that before? Does the word lazy tell you what it might be?
Yes, I know. So what lazy does, it waits for the previous things to be finished. So basically, if you're assigning a lazy variable a value of some other variables, so it's gonna wait until those variables are finished, so or properly assigned. See,
Not exactly, Shahrukh. Lazy does not wait for other things to finish. Lazy is only going to do the work if necessary. If you have declared this, lazy variables are always declared as blocks, you will see, as a closure. Why is that? This block of code is not going to be executed until you read this variable from somewhere in your code. That's why it is lazy. So even if the things inside are ready and available, but they have not been, this variable has not been called, it will not have a value because nobody needs it. That's what this lazy is doing. It's just like a lazy person. They won't move unless it's necessary. That's what this is doing. So these are the things, two things you need to know. One is that lazy variables, you will always have a closure in which you declare, and whatever is being returned is the value of that variable from the closure. And this block does not get executed until this is called from somewhere in the code. So for example, if we open this app but don't create any values, there is nothing to save, there is nothing to read, this won't come into being. That's what it means. So that's what the lazy variable. And why is it declared as lazy variable? Because exactly the same reason. You may not want to, unless, let's say your core data model is on somewhere there, but the user never reaches that screen. Why would you want to read and, do all of that work if they're not going to even go there? So that's what this is. And if you can follow the trail here, this persistent container is being requested from here. So your context is a part of the container that we just saw there. So by now, what you should have is, and if you don't have it, we will, describe it some more, an understanding of how core data is built into this app. That what core data actions are happening when you hit the plus, and how this list is being taken out of the core data model. And there is one more thing which we haven't looked at in this event. You see, there is an extension of the event that creates a new event, right? Adds a new row to our list. There is another extension to a collection class. So the collection is a Swift class, right? It's a part of the foundation framework. We are extending it with a function called delete. So it will receive two arguments, an event and an index. And what it does, uh, oh no, I'm sorry. The delete function receives two arguments. This is the description of the collection, that it's a collection of events with each one with an integer index. And what the delete function does is it gets an index set, could be an array of integers, for example. And for each of those indices, it calls the delete function. From the managed object context, it calls a delete. So this managed object context is basically a collection of these events. And why is that? Because that's how we defined it. We are saying that our data model is a bunch of these entities, and each entity has this attribute. So it is a collection of events. And here we are saying that if we call the delete function, remove that value on which the delete was called. And this here it says self $0. What does that mean? Self is referring to the class, the object of this class, which is the object of a collection. And $0 is Swift shortcut for any variables that are being passed in a closure. So this is a closure here, right? What you're saying is that over here, the first, whatever is the, actually, I'm sorry, that's not the closure we're talking about. This is the closure we're talking about. For each has a closure. And if you look up the for each documentation, you will see that it is actually, it takes an argument, index in, and this is how you can also write it. These two are equivalent. These two lines are exactly equivalent. What you're saying is that this is the expanded version. It receives one argument called index, and then you use it here. But Swift gives you a shortcut. It says that instead of saying that there is one argument and you use it, you just say $0, and this is implied that whatever is the first argument, plug it here. So these two are equivalent. So just like there is $0, there is $1, 2, 3, 4, any number of arguments that the closure receives, you can get, you don't have to do this part of it. So this is our delete function. And where do you think it is being called? When you swipe, it gives you a delete action, right? When you say edit, it lets you select multiple of them. Okay, it does not let me select multiple of them. It lets me work with them one by one without having to swipe each one. So when I say delete this one, right? So that delete should invoke this method. It will disappear from the collection, and that change will propagate. It will come here to this one. This events will have changed, so this view will get updated. That's your view model doing its thing in the background due to property binding. So where is this delete? The delete is right here. For each row you put in the list, you have an on delete, and within it, you're saying, okay, when this delete is called, delete whatever indices were selected. It only allows us to select one, so it will pass that one index, and it will delete that. And then the whole process, it moves through the entire process, and the data comes back. The signal comes here, and it gets removed from here. Okay. So far, so good. So, okay, we'll make a change to it. That's why we will start getting into doing these things, some of these things. But any questions so far? So you should by now start seeing what core data is doing in the background, right? So now what we want to do is we will make a change to this. What we will do is we'll make a simple change, more from the point of view of learning how to do this kind of a change in core data. So what we will do is we want to add a row number to the row in the list. So every time we add a row, we want it to have a number to it. So to be able to do that, we need to save a row number with each row. And the idea is that if I have 5 rows here, let's say they were all created in sequence without anything being deleted, the number would be 1, 2, 3, 4, 5. And then if I delete row number 3, it should still say 1, 2, 4, and 5. That's the idea. We're not printing the row number as it appears in this list. Think of it as an ID of that row. So we'll add that. So we'll first add it to the core data model, then we will add it to the event.swift in the create function we need. And then we will update in the content view. Okay. So let's get started. Let's do it in the core data model. So in our core data model, we have this entity event. We want another attribute. We have a timestamp. Oops, I clicked it twice. I have to get rid of this one. So just click minus if you want to delete anything. So this attribute, I'm going to call it ID. And we have to give it a type. And since we have said we are going to use an integer, we'll use integer 16. Core data, when it is saving an integer, it needs to know how much space to allocate. Think of this as column types in your SQL table. SQL table have those tiny int, medium int, big int, all that, right? So this is like that. Integer 16 is a smaller integer. It will still be probably good enough for millions, if not billions of values. So we'll just use integer 16. So now our each event can have an ID and a timestamp, right? So if you had a more complex row of things there, information to store. So for example, if this was a notes app, right? And you are creating, each one of them is a note that you have added, then you may want to store the data of the note here, display the data. So you may have an object here called note data, which is of the type string. All of those things you can add. Right now, we'll just add one simple ID. So if we have an ID, we want to be able to save it. Okay. So here, when we create this ID, we are assigning a timestamp, right? Along with it, we will want to give it an ID. And what is its value? What we can do is we can pass the value as an integer and use that here. And this value, then it becomes the job of whoever is creating it to provide it an ID. Okay, you may get these errors with core data. We have added this, right? Has a member called ID. We have added it. All you need to do is to get rid of this, just say product and build. Cannot. Okay, so the error changed. Now it's not complaining that it does not have an ID. It is saying cannot assign value of type int to type int 16. Because int has a bigger scope than int 16. It cannot assign it automatically unless you say I take responsibility, convert it into an int 16, even if there is an overflow, I take responsibility. Overflow means, let's say int has a capacity from 1 to 100 and you try to assign 101 to it. It's going to overflow, and just the bits and bytes will be not 101, but it will still be something from 0 to 100. Overflow probably just goes to the beginning. So that's what the responsibility we take when we said convert it to an int 16. So this here now, when we create an object, if we give it an integer ID, it will be displayed here. Okay. So how do we now we've changed our create function. We go to the content view class now. And in our create, already it is complaining that you're missing argument, the ID. So we need to pass an ID here. The simplest thing you can do is right now, if you just want to test it, you just say ID 5 and you run it. And now you will see that because these were already there. Oh, we haven't actually used it in the display. I'm sorry. Let's do that and then we'll take a break. So we have created an ID of 5. In our display, when we are displaying the list, we are only printing the timestamp. We're not printing the ID. So what we can do here is we can, over here, we can say event.id and maybe put a colon in between. So now when we run it, we changed our data model, right? The previous ones were saved without an ID, so it may have some default value, 0. Any new ones we add will should have the value of 5 that we have hard coded. So you see, this is now, I can actually, why won't it? You can close the app, kill it, and open it, and you will see that this 5 will get retrieved, these rows. Right, let me kill it. And when I retrieve it, 5 came back. And the others are still 0 because that's the default value. So what we have done is we have added a new property to our data model, the ID, and we have already seen its effect. We added it to the function that creates them, and we added it to the display along with the function call. So right now it's 10:14. We will continue this. This is, I find that this is one of the more complex topics we have dealt with. So let's take a break here. Good time to take a break. And when we come back, what we will do is we will look at how to get the number, the actual row number. And when we do that, we will run into this fetch request and we'll see how to avoid that. So those are the things we'll do. So take a break. We'll meet again at 10:35.